Welcome back to vSpice. In this session, we'll continue with mastering alarms. In session 3, we'll focus on alarm system design. So, alarm system design in the sense, we'll focus on hierarchy of risk control and alarm system hardware and software and how the system size affects the design and management, meaning depending on the number of alarms, how it affects the design. Okay. Then designing an individual alarm. So meaning the criteria for designing an individual alarm and when is it appropriate to provide an alarm. So these are the five aspects we are going to deliberate in this session. Okay. So, yeah, hierarchy of risk control. Okay. Before going into the details, friends, design of any plan should always consider how its objectives can be achieved, isn't it? And balance the risk that may arise, right? So the hierarchy of risk control is recognized as an effective way of managing risk and highlights that alarms are relatively unreliable solution. Okay. So plan design should always aim to apply risk controls. So what are all the risk controls? Let's see. So one is this inherent safety, meaning we need to eliminate or minimize hazards so that there is no chance of a hazard occurring. Alarms are not required for inherent safety system. Okay, you got it? Right, inherent safety. So this is one of the aspect. Then passive engineering. So passive engineering in the sense, design and build plan to withstand the maximum possible range of operation conditions. Meaning, you know, process excursion will not lead to loss of containment and alarms are not required. You got it, friends? Passive engineering, meaning the design and build plan to withstand the maximum possible range of operating conditions. So we have to take care of the engineering side, passive engineering. Okay. And we have active engineering. So install devices that will automatically transfer a process to a safe state when activated by an excursion. Okay. So examples include, SIS and pressure relief valves that operate without any human intervention, isn't it? So alarms are not part of their operation, but have a key role in reducing the demand on the safety system because the operator can intervene before the activation point is reached. So this is the active engineering. Then we have administrative controls. See, for example, competent working people have to define procedure and avoid problems. Define procedure, avoid problem, and also know how to respond if things go wrong. So which may be indicated by an alarm. So this is about the administrative control. Then we have a mitigation measures. So arrangement to reduce the consequences of an event. Friends, process alarms are ineffective at this stage because the hazard has already occurred, but protective system alarm, like for example, the fire and gas detection, may have a role in triggering a response that mitigate the risk, meaning evacuate the area, active firefighting, all these. So these are the five aspects of hierarchy of risk control: inherent safety, passive engineering, active engineering, and what administrative controls and mitigation. So this is a important things as part of hierarchy of risk control. Then we go into the alarm system hardware and software. Okay, maybe before going into the detail, some of the components that make up the alarm system will have other uses or to be provided almost by default. In particular, take a case, the sensors that measure conditions, right? The transmission mechanism, all these transmission means cable, right? And the devices that receive the data are likely to be part of the BPCS and SIS, right? So here the hardware and software used to communicate alarms to the operator are of most interest and the need to be optimized through design. So features to consider when selecting a new system or evaluating existing system include. So what are all those? Let's see. number of alarms that can be handled. How many number? Like 1,000, 2,000, 5,000. So this is one of the aspects we should consider while designing the hardware and software, right? Then time taken to process a data and activate an alarm. So that is very, very important. Time taken to process data and activate an alarm. Methods of communicating and displaying. How you want to present this? I want to present with a flash, or you want to present in a big gigantic screen. All these. Then options for, sorry, not operation. This is options actually. Sorry, a typo error. Options for classifying and prioritizing the alarm. So you need to prioritize it. Okay. Right. So these are the things. And few more. Methods for communicating and displaying alarms. Okay, I think it is getting repeated. Yes, it is getting repeated. Okay. So the next one. Capability or again repeated. Yes, it is two are getting repeated. Never mind. So capability for logical processing of alarms. Capability of logical processing of alarms, and also the mechanism for applying and managing suppression, shelving, overrides, and inhibits. We are going to talk about this also in the subsequent session. Okay. So mechanism for applying and managing suppression. Then options for handling highly managed alarms. This is also we are going to talk. What is highly managed alarm? Okay. Then data logging capabilities for problem diagnostics by the operator and monitoring the alarm system performance. And finally, the security arrangements. So these are the factors we should consider when selecting a new system or evaluating the existing system. Okay. Okay, friends, got it? So number of alarms, time taken to process data and activate an alarm, method of communicating and displaying alarm, option for classifying and prioritizing the alarm, capability for logical processing of alarm, mechanism for applying and managing suppression, options for handling highly managed alarm, and data logging capabilities and security arrangements. Okay, right. So this is about the alarm system hardware. The next one is very important and interesting. How the system size affects the design and management. Okay, for example, take the case here. If your number of installed alarms per opter is under 100, then the approach is simple technology, like you have to have an annunciator, likely to be acceptable, right? So operational problems may often be solved by individually tailored solution. Okay, so it's a small annunciator kind of thing, right? One significant risk is that the operator and alarm system may have a safety role that is not fully appreciated. In addition, poor alarm system performance may not be recognized and given priority. Anyway, the point is under 100, it's a very simple technology, right? Okay. Then if it is 100 to 300 numbers, then if annunciator based system are used only on their own, they need to be very carefully designed to ensure good usability. So mixed annunciator and computer based alarm display can be effective in this case. Okay, that is the point. Then if it is 300 to 1000, then we should have a sophisticated computer based alarm handling with powerful tools for logical processing and suppression of alarms. Okay. And if it is over 1000, means a major alarm system, like very big, significant investment throughout the life cycle, which needs to be developed or maintained in line with the industry practice. So this is how the system size affects the design and management. This is just I want to give you an overview. The point is based on the number of alarm, the system approach varies, friends. That's a point. Another important one, designing an individual alarm. Every alarm configured on a system needs to go through a design process. It is not just like that, right? Every alarm we give. No, it is going through a design process. So this should include confirming whether it is justified and can be configured to support the operator. That is the main point. So the specific aspects of design for each alarm include the condition that will activate the alarm, meaning whether normally a static set pointer, but activation may be dynamic, right? Based on the rate of change or discrepancy between two sensors. So point is the condition that will activate the alarm need to be take note, okay, focused. Then alarm description, that is also very important when we design an individual alarm. Then alarm category, what type of category? So process, safety, all these. Then what priority? What is high, low, medium, all these. Then logical processing. So once designed, it should be checked to confirm the alarm will actually support the operator. So that is the point, right? Okay. And another point is a particular concern is that whether the alarm configured will actually give the operator enough time to respond. So that also matters a lot when we design a alarm. Okay. Now the last for this session. When is it appropriate to provide an alarm? We can't do it everywhere any time, right? Yes. So number of factors can be considered when deciding if an alarm is required. What are all those factors? Okay. Process safety, environmental, asset protection, production quality, personal safety, alarm system availability, alarm system communication. Okay. So alarms, okay, maybe these are the points. In fact, at this point of time, we should focus to give a alarm. Okay, these are the factors. Okay, alarms are maybe proposed as a requirement during safety study, right? As it has a layers of protection, low poll, all these, right? However, these tend to look at issues in relative isolation. Relative isolation means it do not take into account wider consideration. Wider consideration means a separate review and rationalization to take place to confirm the proposed alarms are appropriate with feedback to the original study. Okay, that kind of a brainstorming we need to take. So yeah, okay. The bottom line, whether whatever its source, every alarm should be justified, properly engineered, and be consistent with the overall philosophy and risk assessment. That's all, friends. Okay, I have for this session. Okay, so this session 3 I will end, and many more to come. So many more in the sense it depends, of course, as I highlighted, the highly managed alarm. What is highly managed alarm? HMA, that also I will talk, wherein in that we'll focus on types of HMA and protective layer alarms. All these aspects we'll look into it. And HMA management also will talk. Of course, it depends on your interest also. If nothing, nobody is showing interest, then I will not continue this. Okay. Then I straight away go into another important thing actually, practical consideration for alarm design. What are all the practical consideration for alarm design? Okay, in that I'm going to talk many more actually. Types of alarm. Okay, it's a very important. The types of alarm means absolute alarm, bit pattern alarm, calculated alarm, system alarm, deviation alarm. Very important aspects. And first up alarm, you would have heard, right? First up alarm, and how to select alarm settings. So those things also I'll focus. Okay, stay tuned and take care. Bye bye.